Welcome to FPGA Magic, where FPGAs are easy to design. For our first example, we're going to create a new project. The name of the project is also the name of the directory where the project will be stored. Since we have no files, we won't store any, and we will use the FPGA that's on our demo board. The first thing we do is create a block diagram and save it as our top name. Once we've done that, we can double-click on the block and bring up all of our libraries. And the first thing we're going to do is select our serial I/O and place it on the block diagram. We also have several Ethernet variations that you can use. Second, we're going to drop down and put in a port so that we can turn on some LEDs. These are 16-bit ports. And if you don't use all the bits, it's okay because the compiler will take out the unused portions. And lastly, we're going to put in a WS2811 pixel driver, and we have 4 of those in our demo board. So the easy thing about our design process is all the modules just daisy chain. Once you daisy chained them together, you feed it back to the first module, and you're done. We have 3 outputs and 3 inputs. So if we double click, we can say input, and we can add that. So, and then outputs. After we get our outputs hooked up, we're going to rename them. The other thing of note is we use the clock out of our chosen interface, I/O, and drive it to all our modules. Otherwise, it's just easy daisy chaining. When you use a large output with multiple bits, you need to label all of them, even if you don't use them all on the I/O pins. We have 4 LEDs we're going to drive, so we're going to have 4 on the output. We have 4 WS2811 LEDs, but they only require 1 pin since they're daisy chained. And we'll label our clock input and our UART input. Once we've defined all the pin names, we can go up and run the analysis, and the compiler will compile the design and find all the I/O pins. And this is helpful when we go in and define all the pin numbers. So if we go up under Tools, if we go up and under Assignments, Find Pins, we can go up and define all the locations for the pins. And since we're using our standard design, we know where all these pins are. Once all the pins are defined, our design is done, and we can do a full compile. And this will create the programming file. So once the compile's done, we'll want to open the programmer and configure our FPGA. And we just click Start, and automatically our FPGA is configured. Easy. Next, we'll bring up our serial port driver, and we'll show that it's really easy to talk to our board. It's a standard interface with a standard message set. So regardless of which interface you use, it's still the same message set. So what we're going to do initially is read the first 16 words. And once we send this, this will show the first 3 modules. This is the ID followed by the length, and then we have a version number for our serial port. Same thing, ID for the port, it's 3 words long, and then we have a blank port value. And then the WS2811 ID, word length, and then a bunch of empty words. What we're going to do first is we're going to write to the single port and turn on the LEDs. And then we'll turn on the opposite 2 LEDs with a different command, sending a 05 instead of a 0A. And you can see this in the display. Lastly, we're going to send the bytes to turn on all the WS2811 LEDs. And when we send this, you can see all these LEDs come on. So in just a few minutes, we've designed, compiled, programmed, and tested our first FPGA design.